Today we are going to learn about the supplementary units. Beside the seven fundamental and the basic units, there are two more units called as supplementary units. Plane angle d theta and the solid angle d delta. The plane angle d theta, we are going to see first that is a plane angle d theta. This is a ratio of the length of the arc of and circle to the radius of the circle as shown in the figure. Thus, d theta is ds upon r is the angle subtended by arc at the center of circle. ds means the distance, r means the radius. It is measured in the radian and the angle theta is the radian is denoted by theta. Whatever the radian is there, it's denoted by theta c. Solid angle. This is the three-dimensional and longue of d theta and it is defined as the area of proportion of the surface of the sphere to the square of the radius of the sphere. It means that there are three-dimensional and angle of the d theta which is defined in the area portion where the surface of the sphere to the square of the radius of the sphere means that d delta equal to dA upon r square is a solid angle subtended by the area ds at O as shown in the diagram. Here you can observe that there a diagram is there, figure 1.1, the plane angle d theta. Its the measurement is the Stearns. A sphere of this radius r has a surface area 4 pi r square. As you know that sphere surface area is 4 pi r square. So we are going to introduce this formula in this. Thus the solid angle subtended by the entire sphere at the center is delta equal to 4 pi r square upon r square. We have already considered that r square. dA means its area. So it is 4 pi r square upon r square, that is 4 pi sr. So here are some examples are also given. First example, what is a solid angle subtended by the moon at the point of earth given in the diameter of a moon is 3474 kilometers and its distance from the earth is 3.84 into 10 raised to 8 meters. So the solution will be the solid angle subtended by the moon and the earth. So what is the solid angle subtended by the moon on the earth? That is area of the distinct of the moon upon the moon minus earth distance square. So area of the disk of the moon is pi into 1.737 into 10 raised to 3 and bracket close, that is square, upon 3.84 into 10 raised to 5 and that is also square. If you divide this, we get answer is 6.425 into 10 raised to minus pi SR. So next, the relation between the radian and the degree is pi radian is equal to pi equal to 180 degree. 1 radian equal to 180 upon pi. Means the measurement we are going to measure according to 180 upon pi, that is 180 upon pi value that we know what is a pi value, that is 3.1415 equal to, if we divide this we get 57.297. Similarly 1 degree pi upon 180, 3.1415 upon 180, that is 1.745 into 10 raised to minus 2 radian. 1 degree equal to 1060 dash and 1 dash equal to 2.91 into 10 raised to minus 4 radian. 1 dash is equal to 60 and 1 equal to 4.847 into 10 raised to minus 6 radian. The convention of the use of SI units. So what is a convention and what is the use of SI unit? We have to see now. The unit of every physical quantity should be represented by symbol. Every physical quantities which you are going to introduce, it will be have some symbols. Full name of the unit always starts with the smaller letter even if the name is after the person. Whatever the after the person, if the name is given, then also the unit is always start with the small letters. Example 1 Newton, 1 joule. But the symbol of the unit name after the person should be in a capital letter, that is N after scientist Newton, J after scientist Joule. So third is that symbol for the units do not take a plural form. Plural form it doesn't take. For example, if the force of 20 Newton and not 20 newtons or not 20 ns. The symbols for the unit do not contain any full stops. It does not contain any full stop at the end and recommended later. That is example 25 kg and not 25 kg dot dot. The unit of physical quantities in a numerator and denominator should be written as a ratio of. Example, the SI unit of the acceleration is meter per second square or meter second square, but not meter per second per second. Use of combination of the unit and symbol for the unit is avoided by when the physical quantity is expressed by the combination of two. Example, the unit of joules per kg, K is the correct while joule per kg, K is not correct. The prefix symbols used before the symbol of unit. The prefix symbols, unit symbol, constitute a new symbol for the unit which can be raised the positive or negative power of 10.